Hello class, today we're going to talk about lesson 5.2, using intercepts. Our objectives tonight are we can find the x and the y intercepts and interpret their meanings in real world situations, and we can use the x and y intercepts to graph lines. Our first vocabulary alert, we've got the y-intercept, which is the y-coordinate of the point where the graph intersects the y-axis. Always, the x-coordinate of this point is 0. So we have a point where it is written as 0 and some y value. The y-intercept is the x-intercept is the x-coordinate of the point where the graph intersects the x-axis. The y-coordinate in this case is always 0. So the x-intercept is a point where we have any x value with a y value that is always 0. Alright, let's look at our first example. Alright, so we need to find the x and the y-intercept. So, we're going to first look at the y-intercept, where the line crosses the y-axis, which is right here. And remember, the coordinates of the y-intercept, the x value is always 0, and then the y-coordinate is just the y value of the point. And if we look at the graph, the y value is at -3. Alright, now let's look for that x-intercept, which means we need to look at where does the line cross the x-axis. It's right here at this point. So let's write down what our x-intercept is. So remember, the x-intercept is a point, and this time the y value is always 0. The x value is the x value of our point, which is -4. So our y-intercept is at 0, -3, and our x-intercept is at -4, 0. Let's see if we can do this also with an equation. So to find our x-intercept, we're going to plug x in for x and 0 in for y into the equation 3x minus 2y equals 12. So we have 3x minus 2 times 0 equals 12. 2 times 0 is 0, so we have 3x minus 0 is equal to 12. Well, 3x minus 0 is just 3x. So we've got 3x is equal to 12. And now we're going to solve this for x. So we're going to divide by 3. And x is equal to 4. So our x-intercept is 4, or the point 4, 0. Now to find the y-intercept, we're going to do the same thing, except we will plug 0 in for x and y in for y. So we have 3 times 0 minus 2y equals 12. Well, 3 times 0 is 0. 0 take away 2y is just -2y. And now we're going to solve this for y. So to do that, we're going to divide both sides by a -2. And y is going to equal -6. So our y-intercept is at -6, or the point 0, -6. So we found the x and the y-intercept of the equation 3x minus 2y. Another method you can use for this is to simply just cover up the variable that you are not trying to find the intercept of. So if you're trying to find the x-intercept, you cover up the term that has the y, and then you solve for x. And if you want to find the y-intercept, you cover up the term with an x in it, and you solve the remaining portion of the equation for y. Alright, so our next example is a travel application. We have the Sandia Peak Tramway in Albuquerque, New Mexico travels a distance of about 4,500 meters to the top of Sandia Peak. Its speed is 300 meters per minute, and the function f of x equals 4,500 minus 300x gives the tram's distance in meters from the top of the peak after x minutes. We need to graph this function and find the intercepts, and then we need to represent or interpret what each of the intercepts are. Alright, so since we can't have time and distance be negative, we're going to pick several non-negative x values. So let's use 0, 2, 5, 10, and for our last one, because we're trying to find the intercepts, let's try to figure out what x value will give us an f of x equal to 0. So let's start by finding the f of x values when we use x equals 0, 2, 5, and 10. So we're going to have 4,500 minus 300 times 0. Well, 300 times 0 is just 0. And 4,500 take away 0 is just 4,500. Okay, now let's do that for 2. 4,500 take away 300 times 2. Well, 300 times 2 is 600. So 4,500 take away 600 is equal to 3,900. And let's do 5. Plug 5 in for x. 4,500 take away 300 times 5. Well, 300 times 5 is 1,500. So 4,500 take away 1,500 is equal to 3,000. Now let's plug in a 10. 4,500 take away 300 times 10. Well, 300 times 10 is 3,000. So 4,500 take away 3,000 is just 1,500. And now we are going to solve that last one. 0 equals 4,500 take away 300x, 4x. So to do that, let's start by adding 300x to both sides. So we can result in 300x equals 4,500. And to solve for x, what we can do is just divide both sides by 300. So x is by itself. If both numbers have 2 zeros at the end, we can cross out the zeros. And 45 divided by 3 is going to just give us that x is 15. So we can put 15 into our x column. Alright, we've got our ordered pairs. Now let's graph it. Alright, so our x-axis is time in minutes. Our y-axis is the distance from the peak in meters. And we're titling our graph Sandia Peak Tramway. So we've got the point 0, 4,500. So from our origin, we're going to go up. In fact, our y-axis is going by 500s. Our x-axis is going by 2s. So from 0 on our x, we're going to go up to 4,500, directly between the 4,000 and 5,000. Then at 2 minutes, we have 3,900 as our distance. So from 2, we'll go up to just almost to 4,000. And plot our point. At 5 minutes, we've got a 3,000 distance traveled. So 5 is between the 4 and the 6. So we'll go between 4 and the next line and go up to 3,000. At 10 minutes, which is right between the 8 and the 12, we traveled or have 1,500 or 1,500 feet remaining, or meters. So we put a point there. And then at 15 minutes, which is between the 14 and the 16, we're at the peak. So there's no distance to the peak. Now, because we can have fractions of minutes and fractions of distance, we're going to actually connect our dots with a nice straight edge. Okay, so we've done one part of the question. We have graphed it. Now we need to explain what each intercept represents. So our y-intercept, or 4,500, this represents the starting distance from the top when the time is equal to 0, when we're just starting. Our x-intercept, 15, this is the time when the tram reaches the peak, and our distance to the peak is 0. So we finished that example. We can move on to our next one. All right, so we are going to graph this linear equation by using the intercepts. So we're going to take 2x minus 4y equals 8, and we're going to find the x and the y intercepts. That is our first step, finding the intercepts. So to find the x-intercept, we're going to just plug 0 in for y into the equation. So we've got 2x minus 4 times 0 is equal to 8. So now we're going to solve this for y. So 4 times 0 is 0. So 2x take away 0 is equal to 8. And 2x take away 0 is just 2x. So 2x equals 8. We can divide both sides by 2 to get x equals 4. So our x-intercept is the point 4, 0. To find our y-intercept, we're going to plug 0 in for x and solve for y. So we have 2 times 0 minus 4y equals 8. Well, 2 times 0 is 0. 0 take away 4y equals 8. Well, 0 take away 4y is negative 4y is equal to 8. So to solve for y, we'll divide both sides by negative 4. So y is equal to negative 2, and our y-intercept is the point 0, negative 2. So now we can move on to step 2, graphing the line. So to do that, let's start by drawing ourselves a coordinate system. So on our x-axis, we're going to go by 1s, and our y-axis, we're going to also go by 1s. So now let's graph the points. We've got the point 4, 0. So from our origin, we're going to go right 4, and we don't have to go up or down anything, so we're going to just plop a point there. We've also got the point 0, negative 2, so we're going to go back to the origin and just go down 2 and plot a point. Now we can connect those dots with a nice straight edge. So we finished graphing the line 2x minus 4y is equal to 8. Let's go to our last example. Alright, so we've got 2/3 y equals 4 minus 1/2 x. Our first step is to write the equation in standard form. So the first thing we can do is actually let's rewrite our equation. We have 2/3 x equals 4 minus 1/2 x. Now let's think. We need to multiply everything in the equation by a common denominator of 2/3 and 1/2. Well, the common denominator between 2/3 and 1/2 is 6. So we're going to multiply everything by 6. 6. All right. 6 times 2/3, the 6 and the 3 can reduce. 3 turns into 1, 6 turns into 2. So we've got 2 times 2x is going to give us 4x equals 6 times 4 is 24 minus the 6 and this 2 can cancel out. The 2 turns into a 1, the 6 turns into a 3. 3 times 1 is 3x. So in fact, I meant we have 4x minus 24 equals 3x. 4y equals 24 minus 3x. So now we need to get that 3x onto the other side to get this in standard form. So we will add 3x. So that's going to result in 3x plus 4y equals 24. Now we can move on to step 2, which is finding our intercepts. So to find our x-intercept, we're going to plug 0 in for y and then solve for x. So we've got 3x plus 4 times 0 equals 24, or just 3x plus 0 equals 24, or 3x equals 24. So to solve this for x, we're going to divide by 3. So x is equal to 8. So our x-intercept is the point 8, 0. Our y-intercept, we're going to put 0 in for x, 3 times 0, and we're going to solve for y. So 3 times 0 plus 4 times y is 24, or 0 plus 4y equals 24, or 4y is equal to 24. So now we're going to divide by 4 and get y is equal to 6. So we've got the point 0, 6 for our y-intercept. Now we can do step 3, which is graph the line. So let's draw ourselves a coordinate plane. So this time I'm going to go, each mark on both the x and the y-axis is 2. So I've got the point 8, 0, so we're going to go over to 8 on the x and put a point. We've also got the point 0, 6, so on our y, we're going to just go to 6 and put a point. And now with a straight edge, we can connect those two dots to form our line. That concludes our lesson on 5-2 using intercepts. So for the rest of the evening, I would like you to finish your guided notes by doing the your turn problems. I will see you later. Have a good evening.